Hello everyone. Today we are going to discuss potential distribution over a string of suspension insulators, various approaches to increase the string efficiency, or you can say method of equalizing the potential drop across insulators. What is M? M is the ratio of mutual capacitance of an insulator to the capacitance to the ground. MC is the capacitance of each insulator disk. All disks are identical and therefore their capacitance is same. C is the capacitance of pin to tower. C is the capacity to ground to the capacitance of metal part of the insulator disk to the tower structure. V is the voltage of power conductor. V1, V2, V3 and V4 are the drops across all the four insulators and their sum is V. That is that is equal to the voltage of power conductor. Let us apply KCL at this node and I2 is sum of I1 and IC1. Now, having applied KCL, I1 and IC1 are written in terms of voltage and capacitance, angular frequency, and M. So, first expression is V1 M omega C. Since this I1 current is in the current through the top insulator disk, the voltage drop across this disk insulator is V1. Hence, V1 into admittance of this insulator. Second term is V1 into omega C. Here, V1 is the voltage drop across the capacitance C. As these two branches are now solving the second expression. Let us apply KCL on another node. Hence, I3 is sum of I2 and IC2. Similarly, we can write equations for this equation and later on we can apply KCL on another nodes. Now solving this equation, now simplifying this equation, let us substitute V2, let us substitute V2, obtain the expression in terms of V1. Our aim is to solve the equation in single variable. Now the equation is expressed only in terms of V1. Now applying the KCL on another node and therefore I4 is nothing but the sum of I3 and IC3. Again, we need to simplify the equation and solving this equation for V1 only. Now we have the equation only in terms of a variable V1. See, voltages V2, V3 and V4, they are expressed in terms of V1. Now, having substituted V2, V3, V4 here in this equation, we have expression solely in terms of V1. So, we can determine V1 in terms of V, voltage of power conductor. Efficiency of a string is defined as voltage across the string divided by total number of disc insulators and voltage across the unit near the power conductor. Methods of equalizing the potential across disc insulators. First method is selection of M. Second method is grading of insulator units. Third method is guard ring or shielding of conductors. Selection of M. As we know, M is defined as the ratio of mutual capacity to capacitance to ground. It is very important approach for equalizing the potential across the suspension disk by having larger value of M. Why larger value? What is the maximum value? Increasing the value of M means increasing the length of cross arm. This increases the investment cost. Therefore, utility cannot increase the cross arm beyond certain extent. Therefore, an economical viable option is M is equal to 10. So this is an approximate value of M that is very popularly considered in power system. Grading of overhead insulators. What is the reason of unequal voltage distribution? What is the concept of grading? Is it economical viable? Whether capacitance to ground is equal? Let me reply the first question. What is the reason of unequal voltage distribution? Since we observed capacitance formed between pin of insulator and tower structure. So a leakage current flows through this capacitance. Thereby, we notice unequal current flowing through the disc insulators. Further, all the disc insulators offer identical capacitance. Hence, the voltage drop across each disc insulator is different. Let me reply second question. What is the concept of grading? Since I already discussed current through each insulator is different. Therefore, to equalize the product of current through the insulator disk and its capacitive reactance same, we need to have different disk insulators of different shape and size. Thereby, the product of current and capacitive reactance is same. Next question, is it economical? No, it is not economical at all because it is difficult for any industry to make several types of insulators. Finally, I reply to the last question whether capacitance to ground is equal. Yes, it is considered. Practically, this assumption doesn't lead any significance issues in analysis purpose. Aim to have this grading is potential equalization across all the units. So in this diagram, we consider different types of disc insulators and they offer different capacitance as C1, C2, C3, Cn, Cn plus 1. Now, the current through the capacitance C is IC1. Now, the voltage drop across this capacitance is V. It is also important to notice down that the voltage drop across all the disk insulators is same, that is shown by small letter V. Now, the voltage drop across this capacitance is n times of V. Therefore, you can simply apply Ohm's law and you can determine the current. Hence, the current is IC1, that is equal to ICN upon N. The reason is that the voltage drop across the branch which carries ICN is N times of V. Now, let us discuss the junction where three currents where three currents I n plus 1 I n I c n meet, and just substituting the values of these three currents and solving it, and finally we obtained this expression C n plus 1, and that is equal to Cn plus Nc. This expression is very important and many times a numerical is directly given on this expression. Static shielding. In static shielding, metallic pin to supporting structure charging currents are exactly cancelled out. Thereby, the same current flows through the identical insulator units and produce equal voltage drop across each insulator unit. One can see this diagram. Here you can notice a static shield is connected to the power conductor, and this shield basically helps to cancel out the current between metallic pin of insulator and tower structure. So the total voltage of the insulators is K times of V. Here K is the number of insulator disk. Now for n units, the voltage drop across n units is n times V, because we consider using this static shielding, the voltage drop across each unit is same and that is V. Now remaining units actually K minus N. Hence, the voltage drop across remaining unit is K minus N times of V. Now, you can see this current IN plus 1 must equal to IN, and this ICN must equal to I dash CN. Now, just substituting the values of these currents, and solving them, so we obtained this expression Cn, that is equal to n upon k minus n into C. Please don't restrict yourself here. Keep searching and reading of suitable contents of your need. Thank you.